Differentiating x to the power n. We can use the definition of the derivative to find an expression for the derivative of x to the power n where n is any number. This is called differentiation. So, in my previous PO Maths video, I covered about the definition of the derivative and where differentiation originates. So, as I said in my previous PO Maths video, the derivative of the curve y equals fx is written as f dash x or dy over dx. Now, f dash x and dy over dx both represent the derivative. But we usually use dy over dx when an expression is given in the form y equals. Now, for all real values of n, if y equals x to the power n, then dy over dx equals nx to the power n minus 1. So, in order to find the derivative of y equals x to the power n, we multiply by the power, that is n, and then subtract 1 from the power. And hence, the derivative of y equals x to the power n is dy over dx equals nx to the power n minus 1. Now, for all real values of n, if fx equals x to the power n, then f dash x equals nx to the power n minus 1. So, as I said earlier, we usually use dy over dx when the expression is given in the form y equals. And so, we usually use f dash x when the expression is given in the form fx equals. So, the derivative of fx equals x to the power n is f dash x equals nx to the power n minus 1. And hence, for all real values of n, if y equals x to the power n, then dy over dx equals nx to the power n minus 1. And if fx equals x to the power n, then f dash x equals nx to the power n minus 1. Now, let's take a look at a few examples. Find the derivative f dash x when fx equals x to the power 4. So, fx equals x to the power 4. So, as we saw earlier, for all real values of n, if fx equals x to the power n, then the derivative f dash x equals nx to the power n minus 1. So, we multiply by the power, in this case 4, and then subtract 1 from the power. Then, f dash x equals 4 times x to the power 4 minus 1 equals 4 times x to the power 3 equals 4x to the power 3. Now, fx equals x to the power minus 4. So, we multiply by the power minus 4 and subtract 1 from the power. Then, f dash x equals minus 4 times x to the power minus 4 minus 1 equals minus 4 times x to the power minus 5 equals minus 4x to the power minus 5. Fx equals x to the power 1 over 4. Now here, the derivative f dash x equals 1 over 4 times x to the power 1 over 4 minus 1. So, multiplying by the power 1 over 4 and subtracting 1 from the power, then f dash x equals 1 over 4 times x to the power minus 3 over 4 equals 1 over 4 x to the power minus 3 over 4. Now, fx equals x times x to the power 2. So, in order to find the derivative f dash x, first we need to write this in the form x to the power n before we can use this rule. Then, using the laws of indices, fx equals x to the power 3 as we added the powers together. So, I've already covered about the laws of indices in my first PO Maths video. If you want, check it out for more details. Now, fx equals x to the power 3. Then, f dash x equals 3 times x to the power 3 minus 1 equals 3 times x to the power 2 equals 3x to the power 2. Fx equals x to the power 6 over x to the power 3. Now, first we need to get this in the form x to the power n before using the rule. So, fx equals x to the power 6 divided by x to the power 3. Then, using the laws of indices, fx equals x to the power 3. As we subtracted the power, 6 minus 3 equals 3. Then, f dash x equals 3 times x to the power 3 minus 1 equals 3 times x to the power 2 equals 3x to the power 2. Now, let's take a look at a few more examples. Find the derivative dy over dx when y equals x to the power 7. So, as we saw earlier, for all real values of n, if y equals x to the power n, then the derivative dy over dx equals nx to the power n minus 1. So, y equals x to the power 7. Now, to find the derivative dy over dx, we multiply by the power, in this case 7, and subtract 1 from the power. Then, dy over dx equals 7 times x to the power 7 minus 1 equals 7 times x to the power 6 equals 7x to the power 6. Y equals 1 over x squared. First, we need to write this in the form x to the power n before differentiating. So, y equals 1 over x squared is the same as y equals x to the power minus 2. So, I've already covered about this in one of my previous PO Maths videos, negative and fractional indices. If you want, check it out for more details. Now, y equals x to the power minus 2. Then, dy over dx equals minus 2 times x to the power minus 2 minus 1 equals minus 2 times x to the power minus 3 equals minus 2x to the power minus 3. So we multiplied by the power minus 2 and then subtracted 1 from that power. Y equals 1 over the square root of x. So the square root of x is the same as x to the power 1 over 2. Then y equals 1 over x to the power 1 over 2. Now rewriting this in the form x to the power n, y equals x to the power minus 1 over 2. Then dy over dx equals minus 1 over 2 times x to the power minus 1 over 2 minus 1 equals minus 1 over 2 times x to the power minus 3 over 2 equals minus 1 over 2 x to the power minus 3 over 2. Now for all real values of n and for a constant a, if y equals a x to the power n, then dy over dx equals a n x to the power n minus 1. So when y equals a x to the power n, then the derivative dy over dx equals a times n times x to the power n minus 1. So we multiply the constant a by the power n and then subtract 1 from the power. And also for all real values of n and for a constant a, if fx equals a x to the power n, then the derivative f dash x equals a n x to the power n minus 1. So let's take a look at a few examples. Find the derivative dy over dx when y equals 3x to the power 2. So y equals 3x to the power 2. Then, using the rule for differentiating a x to the power n with a equals 3 and n equals 2, dy over dx equals 3 times 2 times x to the power 2 minus 1. So, we multiplied the constant a, that is 3 by the power 2, and subtracted 1 from that power. So, dy over dx equals 6x to the power 1 equals 6x. Now, y equals 4x to the power 6 over 2x to the power 3. So first, before differentiating, we need to write this in the form ax to the power n. Then y equals 4x to the power 6 over 2x to the power 3 equals 2 times x to the power 6 minus 3 equals 2x to the power 3. Now to differentiate this, we multiply 2 by the power 3 and then subtract 1 from the power. Then dy over dx equals 2 times 3 times x to the power 3 minus 1 equals 6 times x to the power 2 equals 6x to the power 2. Moving on to another example, find the derivative f dash x when fx equals 20x to the power 1 over 4. So, using the rule for differentiating ax to the power n with a equals 20 and n equals 1 over 4, f dash x equals 20 times 1 over 4 times x to the power 1 over 4 minus 1. So, multiplying the constant a, that is 20 by the power 1 over 4 and subtracting 1 from the power, then f dash x equals 5 times x to the power minus 3 over 4 equals 5x to the power minus 3 over 4. Fx equals x to the power 3 over 2 over square root of 2. So, writing this in the form ax to the power n gives us fx equals 1 over square root of 2 x to the power 3 over 2. Now remember, a can be any number including fractions or surds. So here a equals 1 over the square root of 2 and n equals 3 over 2. Then multiplying 1 over square root of 2 by the power 3 over 2 and subtracting 1 from the power to differentiate gives us f dash x equals 1 over the square root of 2 times 3 over 2 times x to the power 3 over 2 minus 1 equals 3 over 2 square root of 2 times x to the power 1 over 2. X to the power 1 over 2 is the same as the square root of x. Then f dash x equals 3 over 2 square root of 2 times square root of x equals 3 square root of x over 2 square root of 2. So, I've already covered about surds in one of my previous Pure Maths videos. If you want, check it out for more details. So, we learned that we can manipulate surds using these rules. Then using this rule, f dash x equals 3 over 2 times square root of x over square root of 2 equals 3 over 2 times the square root of x over 2. So, f dash x equals 3 over 2 the square root of x over 2.